All right, here we go on another section, another test, new chapter, new part of the chapter. We're going to look today at graphs of trig functions, and these trig functions are going to be in the form y equals a sine bx, and we'll also be substituting the word sine for cosine. Now, I want to talk, this is the first of two tapes that are going to be concerning this topic. Let's dissect this formula right here. A will give us what is called the amplitude, which is another word for height. And amplitude is defined as the absolute value of A. The normal period of this function is 2 pi, so the period of any sine function will be defined as 2 pi divided by b. Now, let's just go back for a minute and review this concept of a function. Do you remember the trig function that I drew on the board today looked like this? The normal trig function has a period of 2 pi, and that just means that every 2 pi the graph completely repeats itself. So if we were to graph it, we would half that period, we would half it again, we would multiply this point by 3, and then you remember the sine curve crossed at the beginning, the middle, and the end. It goes up to the amplitude of 1 at the second point and down to the low point of -1. So that this is a rough sketch of one period of the sine curve. Now, as we look at that sine curve, we can change the amplitude and we can change the period as we make adjustments with A and B. Now, if you're watching this for the first time, if you missed class today, you might be wondering where this graph came from. And I will tell you that it comes from using the values of the unit circle, and that this graph is what we call periodic, that it repeats itself, so it would keep going and going and going this way, and it would also keep going and going this way. So just right off the page both ways. It is an infinitely long function. But we usually, for our purposes, will just deal with one period at a time. Now the sine curve always has this distinctive shape. It starts at 0, it goes up and then down back to 0, and then down to the low point of the amplitude, and then back to 0. It's a two-hump curve, and it follows this basic shape. Now what I'd like to do now, before we talk about cosine, is I'd like to just look at several of these sine curves. Let's do y is equal to 4 sine 3x. Let's talk about the changes in this curve. This one has an amplitude of 4, which just means it is taller than the normal sine curve. It has a period of 2 pi divided by 3. Remember, this is A and this is B. So to draw this curve, we would start with our graph. Notice the graph is always going to have a longer horizontal than it does vertical. We would always start at 0, and we would go to the end of this period, which is 2 pi over 3. And then we would begin to divide this period into 5 parts, or 4 sections. We'll take half of 2 pi over 3, which is 1 pi over 3. We'll take half of pi over 3, which is pi over 6. And remember, literally, when I say take half of, I mean multiply 1/2 times that graph. And then let's multiply this by 3, and that would be 3 pi over 6, which is also known as pi over 2. So there are your 5 points. Then we will put the amplitude on the graph. There's 4 and -4. This graph crosses at the beginning, in the middle, and at the end. It will go up to 4 at the high point and down to -4 at the low point. And there you have one period of y equals 4 sine 3x. Let's look at one more of these. Let's remind ourselves what happens when the graph has a negative in front of it, such as, let me bring this over, -2 sine, I'm going to move it over a tad. I don't have enough room. Hang on, let me see if I can pull this up a little bit. Yeah, there we go. Now, All right, negative 2 sine 3x. All right, so amplitude is 2, period is 2 pi over 3. Again, this is A, this is B. Now, I'm going to circle this negative, but I'm not going to include it in the amplitude. I really don't have a problem with that, but remember I told you your WebAssign is pretty specific. They want the amplitude to always be positive. So here we go again. Let's stretch this out. Let's go from 0 to the end of the period, which is 2 pi over 3. This is just coincidental that I picked the same period for this graph. Let's half it, pi over 3. Let's half it again, pi over 6. Let's multiply by 3, pi over 2. Let's go up to 2 and down to negative 2. And as I explained in class today, when I go to grade this for testing purposes, all of these little pieces get counted as part of the points. So, you know, if you miss something, you don't miss the whole thing. This is all, you know, just fine as far as, I mean, there's a lot of partial credit. Now, this negative does the same thing. Let's go ahead and put our points at the beginning, middle, and end, because that's a characteristic of sine. Now, because this is a negative, instead of going up to 2 first, we're going to go down to negative 2 first. So here you have negative 2 sine 3x. It goes down first and then up. Now, and also in today's classes, we talked about cosine x. So let's look at the basic y equals cosine x graph. And this also comes from, if you were not in class today, we took the cosine values off of the unit circle. Again, the normal period of cosine is 2 pi. So I'm going to stretch that 2 pi out. This is pi over 2, this is 3 pi over 2. If you recognize these are the quadrants. This is quadrant 1, quadrant 2, here it is. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4, but we've laid them out on a horizontal line. Now cosine is going to go up at 1 and down at negative 1, and if you look at your values on your unit circle, you will see that it starts at 1, drops to 0, drops to negative 1, comes back, and goes up. And I just like to think of this shape as a bowl. Now again, this graph, this is one period of cosine, and it continues on infinitely. It continues this way and this way into infinity, but this is one period. Now the shifts for cosine will work exactly like it. We will graph in the form y equals a cosine bx, where a is the amplitude and b in 2 pi over b is the period, just like sine. So amplitude is the absolute value of a, and the period of cosine is the normal period, 2 pi divided by b. In this space here, let me graph y equals 1/2 cosine 4x. Now, with my red, I'm going to mark this is your A and this is your B. So let's just review this. The amplitude then is 1/2. So this is a little short cosine curve. And the period is 2 pi divided by 4, or pi over 2. Let's stretch out. I'm going to push this up just a tad. Let's stretch out one period then of this graph. We're going to go from 0 to pi over 2. We're going to half pi over 2, which would be pi over 4. We're going to half pi over 4, which would be pi over 8. And one more time, let me remind you, when I say 1/2 of pi over 4, just literally take it and do this. 1/2 times pi over 4. Half of means half times. And then times 3 would be 3 pi over 8. There's your 5 points. 1, 2, 3, 4, 5. Now, the cosine has an amplitude of 1/2, so let's just put 1/2 up there and negative 1/2. And then your basic cosine shape goes here, high, cross, low, cross, high, and it forms this bowl shape. All right, in quick review, let's get a piece of paper and let me show you again. This is sine. It goes from 0 to 2 pi. It has a halfway point at pi over 2, and at 3 pi over 2. You know, the sine goes up to 1 and down to -1. This is plain sine without any changes. It crosses at the beginning, the middle, and the end. It goes up at the first point and down to the low point at the fourth point. So this is plain, unadulterated sine. If you want to do negative sine, it does the same thing in reverse. So sine is what we call a two-hump curve. Its normal period is 2 pi and if you have a form y equals a sine bx, your amplitude is the absolute value of a, and your period is 2 pi, which is the norm, divided by b. And in this way, we can make changes. This word can also be changed to cosine, and this is the graph of cosine. Again, look at the period. It is still 2 pi. We've got pi in the middle, a pi over 2, a 3 pi over 2. Here it goes up to 1 and down to -1. And this is normal cosine. And it is a big bowl. This is opposite or negative cosine. It would go like this, like that. That's negative cosine. And negative cosine and positive cosine are one-hump curves, and they look like a bowl. And again, amplitude and period are the same as for sine. So what I need you to do is practice drawing these curves and changing the amplitudes and periods. And then when you feel like you're comfortable with that, we want to go on to our second video on this topic, which involves shifting. So that's all for now, and I'll see you in class tomorrow.